Good morning. I am R. Krishnakumar from Mechanical and Mechatronics Department. Today we discuss about the subject name is Theory of Machine, Unit Mechanism and Kinematics. The topic 4-bar mechanism. 4-bar mechanism. A 4-bar mechanism is one of the simplest and most important mechanism used in mechanical engineering of theory of machine. It consists of four rigid links connecting together by four turning pairs to form a closed kinematic chain. Among these four links, one link is fixed while the remaining three links moves related to it. The mechanism is widely used because of its simplicity, reliability, compactness, and ability to transmit motion efficiently. The 4-bar mechanism forms the basis of many machines and mechanical systems used in industries, automobiles, robotics, and household devices. It is mainly employed for in industries. A 4-bar mechanism is the simplest and most effective widely used in planar kinematic chain consisting of four rigid links connecting by four turning revolute pads to form a closed loop. It's commonly used in transmit motion and force in motion. The four links of the mechanism are generally named as the frame, crank, coupler, and rocker. The fixed link is called the frame. The link that rotates completely about a fixed axis is called the crank. The intermediate link connecting to crank and the follower is called the coupler, while the link that oscillates is called the rocker or follower. The movement of one link causes a constrained and predictable movement in the remaining link. The mechanism operates on the principle of constrained motion, which ensure that the motion of all links remain fixed and controlled. Depending upon the length of the link and the selected as the fixed link, different types of motion can be obtained. Construction. The four links are fixed link, frame, stationary link, crank, input link, rotates about a fixed pivot, coupler, connecting link, connect crank and follower. Types of 4-bar mechanism based on motion. Before going to these types of 4-bar mechanism, one of the important concepts associated with the 4-bar mechanism is Grashof law. The law helps determine whether a link in the mechanism can rotate completely or oscillate. According to Grashof law, if the sum of the length of the shortest and longest link less than or equal to sum of the length of the other two links, then the least one link can make a complete revolution related to others. Mathematically, it is the shortest link and the longest link or the remaining the three links condition is expressed S plus L lesser than equal to P plus Q. This law is very important in mechanism design because it determines the type of motion that can be achieved from the linkage system. When the condition satisfies Grashof law, continuous rotary motion is possible. If the condition is not satisfied, the link can be oscillate. Now we're going to see types of 4-bar mechanism based on motion. Crank rocker mechanism. One link, crank rotate fully, while the opposite link, rocker oscillate. Double crank mechanism. Both input and output links rotate completely. Double rocker mechanism. Both links oscillate without full rotation. Inversion of 4-bar mechanism. By fixing different links, various mechanisms are obtained. Beam engine mechanism, coupling rod of locomotive, Watt's mechanism. Now we will see the application. Before going to this application, based on the motion of the link, the 4-bar mechanism is classified into three major types: crank rocker mechanism, double crank mechanism, and double rocker mechanism. In crank mechanism, one rotates completely while the opposite link oscillates. This type is widely used in pump, compressor, and engine mechanism. In the double crank mechanism, both the link adjacent comparison to the fixed link rotate continuously. The 4-bar mechanism has several important inversions obtained by fixing different links of the chain. An inversion is produced when different links are fixed at one time while maintaining the relative motion between another link. One well known inversion of the beam engine mechanism. In this mechanism, the crank rotates and causes to the beam to oscillate, which in turn operates a pump or piston. Beam engine were historically used in steam engine and pumping system. Another important inversion, the coupling rod of locomotive. In this arrangement, the coupling rod connects to the driving wheels of the locomotive so that the both wheels rotate together at the same speed. This ensures smooth and synchronous motion of the locomotive wheels. Now we will see the application. Automobile steering mechanism, engine linkage, pumps and compressor, robotics and automation system. Advantages: simple construction, smooth motion and transmission, high reliability and high durability. These are the advantages. Thank you.